Okay. So what is aerosols actually? Definition of aerosol. Say in the pharmaceutical product, very few aerosol manufacturer present in India, and if you see the bottle aerosols, you can relate to it is like a body spray or perfumery. These are all the application of aerosols. So aerosol definition: it is a pressurized package. Okay, it's a pressurized package. Very important. Pressurized package. Okay. To deliver the content by the help of a propellant. So over here the content is mixed with the API, the active pharma ingredient, plus your propellant. So propellant is very important part of aerosols. They actually create pressure inside the aerosol body. So the API can be dissolved or suspended or emulsified in a mixture of solvent or in the propellant itself. Okay, the solvents we normally use ethanol, acetone, propylene glycol. These are the solvent we use. Now the propellant can be of two types. It can be either liquefied gas. Okay, it can be either liquefied gas or it can be compressed gas. So in a compressed gas, you have an example of carbon dioxide, okay, nitrous oxide, and as well as you use nitrogen. These are the compressed gas, usually very famous. But the liquefied gas, they have a very important advantage of aerosols because they create also a good pressure, good amount of pressure, and they have a wider range of solubility rather than in compared to compressed gas. So like first of example of compressed gas, the liquefied gas is your chlorofluorocarbons. Okay, chlorofluorocarbons. Now the problem with chlorofluorocarbons, they deplete the ozone layer, and that's why they're very restricted in use. Okay, so normally you have chlorofluorocarbons, you have difluoroethane. Okay, I will just introduce you the nomenclature of aerosols. See, whenever we say aerosols 114, the propellant 114. So if you understand, we can write 114 into this fashion: X, Y, Z, where X is C minus 1, Y is 1 plus H, and Z is the number of fluorine. Okay, so in this case, what is the structure of 114? See, if it is X is equal to 1, so C is equal to how much? Is 2. So 2 carbon. Okay, and then you have fluorine 4. So I will just write 2 fluorine each on the carbon, and then you have hydrogen 0. So remaining I have to add chlorine. So it becomes tetrafluoro dichloroethane. Okay, this is one of the chlorofluorocarbons. That is a propellant. Then you have propellant. You have many other propellant. This propellant, one very important thing is their boiling point is less than 21 degree, that means below room temperature, but their critical point is above room temperature. Okay, and the important is they have a different propellant 11. Then you have propellant A31, that is isobutane. Then you have propellant A17, A capital A, butane, and propellant A108, propane. They are only hydrocarbons. Okay, they don't have chlorofluorocarbons, that is only hydrocarbons. Now after that, if you have other example of hydrocarbons, chlorofluorocarbons, then the next thing is hydrofluorocarbons. Okay, so what is the example? You have difluoroethane, that is propellant 134A, difluoroethane. Then you have chloro difluoromethane, propellant 22, okay, and chlorodifluoroethane propellant 142B. Now out of all these things, there was one question that which propellant belongs to hydrofluorochlorocarbons, poses zero ozone depletion potential. That means it is safe to use. Okay, it was asking a NIPER question. The answer is 152A propellant, which is 1,1-difluoroethane. They have a ozone layer depletion capacity is 0, so that's why it is safe. It is green. But the problem is, apart from the aerosol, we use this propellant in AC of car. Now, even though if you are using as a perfume or body spray, this propellant can cause cardiac disease for the people who have a cardiac problem, or maybe in prolonged use it can causes coronary disease or arrhythmia. So that's why in a perfumery industry, this kind of propellant is, especially in pharmacy, pharmaceutical product, this propellant use is restricted. Okay. Apart from that, after the propellant, since it is pressurized package, the container of the propellant play very important role, because it should withstand a particular pressure. This is also one time GPAT question. What is the range of the pressure a container must withstand? Okay, the answer is 140 to 180 psig. Okay, and we use the temperature 130 degree Fahrenheit. Okay, this is the limit every container should withstand. Now you have a aluminum container, you have a glass container. Okay, different type of container we have. Now the thing is, you can find out these containers from your any slide shares or any other sources. But the thing is, we have the different types